Good morning, students. Today our topic is finding concavity, convexity and point of inflection. You see the first diagram. So in using blue color I have drawn the curve. Okay. So on that I have drawn three tangents. Okay. If the tangent lies below the curve, then the curve is concave upward. Okay, otherwise we can say convex down. So if the tangent line to the graph lies below the graph in the vicinity of the point, then the graph is said to be concave upward. See this curve. Using blue color I have drawn the curve. So I have drawn the tangents at 3 points. So now the tangent line lies above the curve. So that is the curve is concave downward or convex upward. Okay. So on seeing the diagram we can easily identify how it is concave upward or how the graph is concave downward. But if the problem comes, we should know some procedure. So what we have to do? The test of concavity. So if f double dash of x is greater than 0, if f double dash of x is greater than 0 means on an open interval I, so within the interval f double dash of x, that is the second derivative, greater than 0, then the function is concave upward on that open interval. If f double dash of x is less than 0 on an open interval, then the function is concave downward. So the second derivative greater than 0, the function is concave upward. The second derivative less than 0, the function is concave downward. Next we are moving to the point of inflection. So it is the points where the function changes from concave upward to concave downward or concave downward to concave upward. So those points are called point of inflection for the curve. Okay, so we have to collect some points. At that points, before and after that point, there is a change in the nature of the concavity or convexity. That means before, if you consider the point as x is equal to 0, so before that, within the interval, the function is suppose concave downward means after x is equal to 0, within that interval, the function is concave upward. So there should be change in the nature of the concavity before and after the interval of that point. So that those points are called point of inflection. So the points where the graph of the function changes from concave upward to concave downward or concave downward to concave upward. Okay, there should be a change before and after that point about the nature of the concavity. So those points are called point of inflection. So our point of inflection to find, we have to check this. So suppose f double dash of c exits, that is the second derivative exits at that point x equal to c, and f dash of c changes its sign when passing through x equal to c. That means before x equal to c and after x equal to c, there is a change in the sign. Here we are mentioning change. Why? Concave upward means the second derivative positive. Concave downward means the second derivative negative. So it changes the sign positive negative or negative to positive when passing through x equal to c. Then the point c comma f of c is a point of inflection. So see, the second derivative exists agno, and the point before and after interval f on the second derivative sign change aachuna, that point is called the point of inflection. And see the second point, f double dash of c exits at that point of inflection, f double dash of c should be equal to 0. So this is the necessary condition. What is that condition? Before and after the point interval, in interval, the point has to, that is f double dash of x changes its sign. So this is very important. F double dash of c changes sign when passing through x is equal to c, and f double dash of c exits, it should be equal to 0. So point C comma f of C is called the point of inflection. You see that using this result, concavity, convexity and point of inflection, we are going to do the exercise 7.7. Find intervals of concavity and point of inflection for the following functions. Okay, we are going to check the concavity and we are going to find the point of inflection. So first what we have to do, so concavity, to find concavity and point of inflection, so everything has to depend on the second derivative. So you see that first step you have to find first derivative, then you have to go for the second derivative. Second derivative has to be equal to 0. Okay, so using, if you equate to 0 you will get some points, so you have to write a interval using those points. Okay, and from that interval you have to consider each interval separately, and from that you have to take one point and substitute in f double dash of x. Then you have to check f double dash of x is greater than 0, the function is concave upward. F double dash of x is less than 0, the function is concave downward. And you have to check before and after the point. There is a change in the concavity. That point is called the point of inflection. So the first step, you have to find the first derivative. You see that here f of x is equal to x into x minus 4 the whole cube. So you have to find out your first derivative. So here you have to use the product rule. So first x is kept as it is and x minus 4 the whole cube. Using chain rule you have to differentiate. So that is 3 x minus 4 the whole square, and x minus 4 has to be differentiated. When it is differentiated, the differentiation of x is 1 and the differentiation of minus 4 is 0. So the first term is over, plus you have to write the second term, that is b has to be kept as it is, x minus 4 the whole cube. If you differentiate x with respect to x is 1. So from these two, what is common? X minus 4 the whole squared is common. So if you take it out, it is 3x. Here you will have x minus 4. If you simplify, it is 4x minus 4. Okay, so we have found the first derivative. The first step is over. Next, we have to go for the second derivative. So I'm going to find the second derivative. So we are going to differentiate f dash of x with respect to x. So x minus 4 the whole squared is kept as it is, and you are going to differentiate this. 4x differentiation is 4 and minus 4 if you differentiate it will become 0. Plus this has to be kept as it is, 4x minus 4, and you have to differentiate this x minus 4 the whole square, that is 2 into x minus 4. X minus 4 if you differentiate, that is 1. Okay, from these two, what is common? 4 into x minus 4. If you take it out from the first term, the remaining is x minus 4. And 4x minus 4 is taken out. So here, from this 4 is taken out. Okay, so remaining is x minus 1. And 2 into x minus 4 is taken out. Listen here, 4x minus 4. From this term, 4 is taken out. So the remaining is x minus 1. Here you will have 2. The 2 is written here. From this x minus 4 is taken out. So this, the second term is x minus 1 into 2. And 4 into x minus 4. If you simplify, you will get 3x minus 6. So therefore, from this term, 3 is taken out. So 4 3s are 12. 12 into x minus 4 into x minus 2. So second step I have completed. What is that? F double dash of x. So using the second derivative only, we are going to do the problem. So first one, f double dash of x, you have to equate to 0. So when equate to 0, 12 into x minus 4 into x minus 2 is equal to 0. So the constant, when you take it to the next side, it is 0. X minus 4 is equal to 0 means x is equal to 4. X minus 2 is equal to 0 means x is equal to 2. So we get some points. So see the first step, first derivative. Second step, f double dash of x, that is second derivative you have to find. The third step, second derivative is equal to 0. When you equate to 0, you will get some points. So the fourth step, using the points and arrange in the ascending order, and you have to write the interval starting from minus infinity to plus infinity. So here 4 and 2 is we are getting. So minus infinity to 2. Next 2 to 4. Then 4 to infinity. So we have formed the interval. From the points you have formed the intervals. Okay, after that you are going to check the concavity. So for you have to make a tabular column. So first intervals, so the 3 intervals is written here, and you have to check the sign of f double dash of x. So see your f double dash of x, it involves the 2 factors x minus 4 and x minus 2, and f double dash of x is 12 into x minus 4 into x minus 2. So here I am going to check each factor involved in f double dash of x. The first factor is x minus 4, next one x minus 2. Here I am going to check the sign of this factor and the sign of next factor. Next totally I am going to check the sign of f double dash of x. According to that, in this column we will decide the concavity. So see now, first interval minus 2 comma minus infinity to 2. In that we can take 0. Okay, if we take 0, here 0 minus 4 is minus 4, so it is negative. So if you substitute 0 here, it is minus 2, that also negative. And negative into negative, why I am multiplying these two? In f double dash of x, your answer is, what is it? X minus 4 into x minus 2. The 12 is a positive number, so it will become, after this multiplication, after the sign of x minus 4 into x minus 2 into 12 we have to do. So here minus into minus is plus. So plus into 12 is plus. So in this interval the function is concave upward. Next we have to go for 2 to 4. So 2 to 4 we can have the value 3. So if we substitute 3 minus 4, so that is minus 1. So minus 1 is negative. You need not write the number, you have to check, you have to write only the sign. So it is negative. So here 3 minus 2, it is positive. So negative into positive. Why we are multiplying? In f double dash of x, x minus 4 into x minus 2. So that's why we have to multiply. So minus into plus is minus. So if you multiply with 12, it will become minus. So in this interval, the function is concave downward. So next interval 4 to infinity. 4 to infinity we can take 5. So 5 minus 4 is positive. 5 minus 2 is 3, that also positive. If you multiply positive into positive, that is positive. So in this interval the function is concave upward. So you have to give the conclusion. The curve is, or the function is concave upwards in minus infinity to 2 and 4 to infinity. Then the curve is concave downward in this interval 2, 4. So we have completed the intervals of concavity. Next we have to find the points of inflection. So the points of inflection, the first step, f double dash of x and f double dash of x exits means it should be equal to 0. So we have equated f double dash of x is equal to 0. So you are having these 2 points. One is x equal to 2 and x equal to 4. So x equal to 2 you consider. So it is before interval, before the interval of 2. Okay. So in that the f double dash of sign is positive, and after 2 the sign is negative. So there is a change in the sign. So therefore x equal to 2 is the point of inflection. And next one, you consider 4. So and at 4 also f double dash of x is equal to 0. So before before 4 in this interval the function is concave down, so its sign is negative, and after 4 in this interval 4 to infinity your f double dash of x is positive. So therefore 4 also point of inflection. So as f double dash of x changes its sign when it passes through the point x equal to 2. When it passes through the point x equal to 2 means before 2 and after 2 in the intervals there is a change in the sign. So x equal to 2 and x equal to 4 are called points of inflection. So we have to write a point, that means x and y value has to be written. So you take x equal to 2 and substitute in f of 2. What is f of 2? That is a function. So in that the place of x you have to substitute 2. And the same way f of 4 has to be found. So f of 2, if we substitute, it is minus 16, f of 4 is equal to 0. So therefore the points of inflection are 2 comma minus 16 and 4 comma 0. So concavity procedure, so everything is depending on the second derivative. So first you have to find the first derivative, second step go for the second derivative, and the third step you have to equate second derivative is equal to 0. You will get the points, arrange the points in the ascending order and make it as an interval. That is the fourth step. Fifth step, you have to consider the interval. From that you have to take a point and substitute in f double dash of x. The next one, if f double dash of x greater than 0, the function is concave upward. If f double dash of x is less than 0, the function is concave downward. Okay, see the second subdivision. F of x is equal to sin x plus cos x. The interval given 0 less than x less than 2 pi. Okay, in the open interval 0 to 2 pi. So first step, you have to find out the first derivative. If you differentiate f of x, you will get the f dash of x. So sin x differentiation is cos x. If you differentiate cos x, it is minus sin x. So second step, you have to go for the second derivative. So you are going to differentiate f dash of x with respect to x again. So it is f double dash of x. Cos x, if you differentiate, that is minus sin x. So in between you are having minus. Sin x, if you differentiate, that is cos x. Third step, you have to equate f double dash of x is equal to 0. So if you equate, so you are getting minus sin x is equal to cos x. So the values are same, but you have to get the negative symbol. So sin x cos x values, at what angle they are same? 45 degree. So here they are not same. So it is one is the negative of other. So I'll take x is equal to 3 pi by 4 and 7 pi by 4. Both values belong in the interval 0 to 360 degree. 3 pi by 4 means it is, 135 degree. 7 pi by 4 is 315 degree. So in this two values, two angles, the sine and cos, sin x, cos x values are equal, but one is the negative of other. So here 3 pi by 4 is, 135 degree, and 7 pi by 4 is 315 degree. Okay, so we formed the intervals. We have to form the intervals. So 0 to 3 pi by 4. Why we didn't start minus infinity? Because the interval is given here. X square is from 0 to 2 pi. So the starting lower limit is 0. So 0 to 3 pi by 4. Next 3 pi by 4 to 7 pi by 4. And 7 pi by 4 to 2 pi. That is enough. Everything is an open interval. So fourth result is over. Next fifth result, what you have to do? You have to take a point from each interval and substitute in f double dash of x. So interval is written here, and here f double dash of x. You are going to find out. Then you will write the sign of f double dash of x. Here f double dash of x is minus sin x minus cos x. So we have to find some values. So 0 to 3 pi by 4. So 0 to 135 degree. So on that I have taken x is equal to pi by 2. That is 90 degree I have taken. So if I substitute minus sin pi by 2 minus cos pi by 2. Sin pi by 2 is 1. So it is minus 1 minus 0. So the answer is minus 1. So in this interval, the f double dash of x is minus 1. So minus 1 is negative. So the sign of f double dash of x is negative, means it is less than 0. So if it is less than 0, the function is concave downward. Okay. So you go for the next interval, 3 pi by 4 to 7 pi by 4. That is 135 degree to 315 degree. So on that you can go for x is equal to 180 degree. So if you substitute in f double dash of x, that is minus sin pi minus cos pi. Sin pi is 0 and cos pi is minus 1. So minus into minus is plus 1. So therefore here you are getting 1. So 1 means it is greater than 0. So a sign of f double dash of x is positive. If it is positive, means it is concave upward. Next is 7 pi by 4 to 2 pi. That is 315 degree to 360 degree. So, I am going to take 330 degree. What is it? 330 degree. That is equal to. If you want to convert into radian, so what you have to do? You have to multiply pi by 180. So, 0, 0 getting cancelled. So, you are getting 11 pi by 6. If you cancel the 3, it is 11. Here 6 3s are 18. So 11 pi by 6. So I have substituted 11 pi by 6. 11 pi by 6 is what? It is 330 degree. So on which one you have to check? You have to check the f double dash of x. What is it, f double dash of x? Here it is given minus sin x minus cos x. So you take minus sin x minus cos x. Okay, first you are going to find sine 330 degree. That is 330 degree is what? 11 pi by 6. So it can be written as sine of 360 degree minus 30 degree, isn't it? So it lies in the fourth quadrant. In the fourth quadrant, sine is negative, so it is minus. It's a even multiple, so the answer is sine 30 degree. So sine 30 degree is minus 1 by 2. Sine 30 degree, 330 degree is minus 1 by 2. Okay, in the same way, go for cos 330 degree. So how it can be written as? It is cos of 360 degree minus 30 degree. Okay, so it lies in the fourth quadrant. 330 degree lies in the fourth quadrant. In the fourth quadrant, cos is positive and it is a even multiple of 90 degrees. So you have to write cos 30 degree. So what is cos 30 degree? Cos 30 degree is root 3 by 2. So sine value is negative and cos value is positive. Okay, so you are going to substitute here. Put x is equal to 11 pi by 6. 11 pi by 6 is 330 degree. F double dash of x is minus sine 11 pi by 6 minus cos 11 pi by 6. So the minus is written here. Sine 11 pi by 6. Okay, so here only we have found sine 330 degree, that is minus 1 by 2. So it is substituted minus 1 by 2. And minus here cos 11 pi by 6, we have found it is root 3 by 2. So root 3 by 2. So minus into minus plus. So 1 by 2 minus root 3 by 2. Okay, so you see that here you will have the value is 1 minus root 3 by 2. Okay, so 1 minus root 3 value is 1.732 divided by 2. So this is the bigger number. So it has the sign minus. So therefore it is negative. So negative, f double dash of x is negative. So negative means it is concave downward. So the function is concave upward in 3 pi by 4 to 7 pi by 4 and concave downward in 0 to 3 pi and 7 pi by 4 to 2 pi. Okay, so we have concluded the function is concave downward in this interval and the function is concave upward in 3 pi by 4 to 7 pi by 4. Okay, and the next one you have to check the point of inflection. You see that at these 2 points your f double dash of x is 0. Take this point before 3 pi by 4. Okay, so you will have positive, negative, and after 3 pi by 4, if you consider the interval, that interval f double dash of x is positive. So it changes sign from negative to positive, that is concave downward to concave upward, and go for 7 pi by 4. So before 7 pi by 4, in this interval, the function is positive. After 7 pi by 4, in this interval, the function f double dash of x is negative. So therefore, as f double dash of x changes its signs from when it passes through x is equal to pi by 4 and x is equal to 7 pi by 4. You have to substitute in f of x. What is your f of x? F of x is sin x plus cos x. What is your f of x? Sin x plus cos x. So in that you have to substitute f of 3 pi by 4. It is 135 degree. So 135 degree lies in the second quadrant. Second quadrant sin is positive. So 1 by root 2. And the second quadrant cos is negative. So it is minus 1 by root 2. So 45 degree having the same value. So it will become 0. and sine 7 pi by 4, that is 315 degree. So the 315 degree can be written as what is it, 360 degree minus 45 degree. So it lies in the fourth quadrant. In the fourth quadrant, sine is negative, so it is minus 1 by root 2, and cos is positive, so plus 1 by root 2, it is 0. So 3 pi by 4 comma 0 and 7 pi by 4 comma 0, they are called the points of inflection. And coming to the third subdivision, f of x is equal to half into e power x minus e power minus x. So you have to check the concavity and the point of inflection. So go for the first derivative. So half into e power x, if you differentiate, it is e power x. In between you are having minus. E power minus x, if you differentiate, it is e power minus x into minus. So it will become plus e power minus x. The second step, you have to find the second derivative, f double dash of x. So half into e power x. If you differentiate e power minus x, you will get minus e power minus x. So why the minus has come? E power minus x, if you differentiate, e power minus x into minus 1. So that's why this minus is in the middle. So third step, what you have to do, f double dash of x is equal to 0. So if you equate to 0, this half, when you take it to the right side, it will become 0. And e power x minus e power minus x is equal to 0. So e power x is equal to e power minus x. E power minus x can be written as 1 by e power x. If we cross multiply, e power 2x is equal to 1. The 1 can be written as e power 0. So 2x is equal to 0, x is equal to 0. You are getting a single point. And what is the fourth step? Using the point, you have to make an interval. So here the intervals are minus infinity to 0 and 0 to infinity. So the next step, what you have to do, you have to consider each interval, take a point and substitute in f double dash of x. So I have written the two intervals, and f double dash of x is half into e power x minus e power minus x, and you are going to check the sign of f double dash of x. So see now, minus infinity to 0. So in this interval, I'll consider a simple point, x is equal to minus 1. If you substitute here, it is half into e power half into e power, x value is minus 1. So in between you are having minus. So e power minus of minus 1 is plus 1. So it is 1 by e minus e. So when you take LCM, it is 1 minus e squared by e. So that is 1 minus e squared by 2e. So e value is greater than 1. Okay. So therefore it is negative. So the sign of f double dash of x is negative. So therefore the function is concave downward. And you take this interval 0 to infinity, you take a number, take a value, x is equal to 1. Substitute in f double dash of x. So half into e minus e power minus 1. This can be written as 1 by e. So it is e square minus 1. If you take LCM. So the answer is e square minus 1 divided by 2e. So e is greater than 1. So it is positive. So it is so f double dash of x is positive. So therefore the function is concave upward. So concave upward in 0 to infinity and concave downward in minus infinity to 0. So at x equal to 0, f double dash of x is equal to 0. So at x is equal to 0, f double dash of x is equal to 0. So therefore before 0 and after 0 you find the interval. F dash of x changes its signs from negative to positive. So therefore 0 is the point of inflection. You see, f of 0 you have to find out. So half into e power 0 minus e power minus 0. So half into 1 minus 1. E power 0 is 1. So 1 minus 1 is 0. So therefore the point of inflection is 0, 0. Okay. So we'll go to the problem number 3. For the function f of x, 4x cubed plus 3x squared minus 6x plus 1. Find the intervals of monotonicity, local extrema, and intervals of concavity and point of inflection. So you should know the procedure to find intervals of monotonicity and local maximum minimum and concavity, convexity, and the point of inflection. You see, First, we will go for intervals of monotonicity. The procedure is monotonicity. If you want to find, you have to find the first derivative and you have to equate the first derivative is equal to 0. You will get some points. Okay. So using the points, you have to write the interval. Okay. So on that interval, you take a point and substitute take a point in that interval and substitute in f dash of x. Okay, for concavity, we have using the second derivative. But intervals of monotonicity, we have to use the first derivative. What is intervals of monotonicity means? In what are the intervals the function is increasing and decreasing. That only we are going to find out. So, increasing, decreasing depends on the first derivative. Concavity, convexity, you have to use fully the second derivative. But intervals of monotonicity, you have to use the first derivative. And your f double dash of x is greater than 0 means the function is increasing. F double dash of x is less than 0 means the function is strictly decreasing. Greater than 0 means it is strictly increasing. Less than 0 means strictly decreasing. Okay, first we are going to find that. So, see now, f of x is there. You are going to find the first derivative. So, it is a 4 is a constant. X cube if you differentiate, that is 3x squared, plus 3 is a constant. If you differentiate x squared, it is 2x. And minus 6x if you differentiate, minus 6 is a constant. The differentiation of x with respect to x is 1. So, minus 6. And here plus 1, it's a constant whose differentiation is 0. So, when you simplify, 12x squared plus 6x minus x. So, we have found the first derivative. So, what's the next step? It is the intervals of monotonicity. So, we have to deal only with the first derivative. So, first derivative equal to 0. That is 12x squared plus 6x minus 6 is equal to 0. From that, what is common? 6 is common. So, it is 2x squared plus x minus 1 is equal to 0. You get, and 6 when you take it to the next side, it will become 0. So, you are getting a quadratic equation. This quadratic equation has to be factorized. So, the product is minus 2 and the addition is 1. So, we will have and 2 and minus 2. So, if you take the product 2 into minus 1, what is that? 2 into minus 1 is minus 2. When you add, it is plus 1. So, here the coefficient is 2. So, I have divided by 2. So, therefore, 2 by 2 is 1. So, you are getting x plus 1. And here 2x minus 1 is equal to 0. So, the factors are x plus 1 and into 2x minus 1 is equal to 0. So, x plus 1 is equal to 0 means x is equal to minus 1. 2x minus 1 is equal to 0 means x is equal to 1 by 2. So, we have found the point. After that, what you have to do? Using the points in the ascending order, and you have to find the interval. So, here you are having minus 1 and 1 by 2. So, minus infinity to minus 1 and minus 1 to 1 by 2 and 1 by 2 to infinity. So, we framed the interval. And what you are going to check? You are going to check the intervals of monotonicity. So, you have to use the first derivative. So, you have to make a tabular column, take the intervals, and you are going to check the sign of f dash of x, first derivative. So, in the first derivative, you see that it is 12x squared plus 6x minus 6. If you factorize, you see that when equal to 0, I have taken 6's out. So, it is 6 into, what is the factor? X plus 1 into 2x minus 1. So, this quadratic function is factorized. So, the answer is 6 into x plus 1 into 2x minus 1. Okay. So, I am going to check the each factor. First factor is x plus 1. The second factor is 2x minus 1. Then I am going to decide the sign of f dash of x. So, it is 6 into x plus 1 into 2x minus 1. Okay. So, in the first interval, minus infinity to minus 1. So, what point we can take? We can take minus 2. So, if we substitute minus 2 here, minus 2 plus 1. Minus 2 plus 1 is minus. So, minus 1. So, that is negative. And if we take minus 2 here, it is minus 4 minus 1. So, it is negative. f dash of x is a product of these two factors into 6. So minus into minus plus, plus into 6 is positive. So here we have to check the first derivative. If the first derivative positive means it is greater than 0. So therefore the function is strictly increasing. Next one, take the next interval minus 1 to 1 by 2. It is a negative number, it is a positive number, so definitely 0 will be there. So you take x equal to 0. If you substitute 0 plus 1, that is positive. If you substitute 0 here, it is minus 1. So positive into negative. Why we are multiplying? F dash of x is equal to 6 into x plus 1 into 2x minus 1. It's a product of these two factors. Okay, so plus into minus is minus. So the first derivative is negative. Negative means less than 0. If it is less than 0 means the function is strictly decreasing. Take the next interval, half to infinity. You can take what point? 1 can be taken. So x is equal to 1. If you substitute, it is positive. Here 1 is substitute 2 minus 1, that also positive. Positive into positive is positive. If you multiply with 6, the positive number, it is positive. So therefore strictly increasing. So f of x is strictly increasing in minus infinity to minus 1 and half to infinity. And your f of x is strictly decreasing in minus 1 to 1 by 2. Okay. So the next step, first result, we have found intervals of monotonicity. That is, intervals of monotonicity means the intervals at which the function is increasing, decreasing over. Next, we are going to find the local extrema. So local extrema, if you want to find, you can use two tests using the first derivative as well as the second derivative. Here we have found the intervals of monotonicity using the first derivative. So in this problem, I am going to use the first derivative test. You see now, if the function is local maximum, so if I draw the curve like this, see here the function is increasing. So your f dash of x, how it is? It is greater than 0. In this side, your function is decreasing. So your f dash of x is less than 0. So that is, here it is positive, here it is negative. So if the function changes its sign from positive to negative, you are getting a maximum point. Okay, you take the same function. If it is, I have drawn like this. So here the function is decreasing. So your f dash of x is less than 0. Less than 0 means it is negative. So here the function is increasing. So therefore your f dash of x is greater than 0. So here it is positive. So if the function decreasing to increasing, so you will get a minimum point. So f dash or f of x is changes from increasing to decreasing, that is positive to negative, you will get a maximum point, and negative to positive, you will get a minimum point. So in this interval, we can check it. Okay, you see now, when your x, that is the curve passing through x is equal to minus 1. So how it is? Before that, the function is f dash of x is positive. After that, it is negative. So positive to negative, if it moves, you will get a maximum. So as the first derivative changes its sign from positive to negative, the function has local maximum at x is equal to minus 1. Changes its sign from positive to negative when passing through x is equal to minus 1. When passing through x is equal to minus 1, x is equal to minus 1, the function has local maximum at x is equal to minus 1. So next we have located where the function has local maximum. At what point? X is equal to minus 1. You have to find the maximum value, that is y value. So x equal to minus 1, you have to substitute in f of x. Okay, so f of x, if you substitute minus 1, you will get the answer as 6. So the maximum value is 6, which is obtained at x is equal to minus 1. And you see that next point you have to take half, because minus 1 and half is, they are critical numbers. So therefore f dash of x we have equated to 0. You will get these 2 points. So in that point also you have to check. So before half in this interval, the function is negative. That is f dash of x is negative. Not the function, f dash of x is negative. So after 1 by 2 in this interval half to infinity, f dash of x is positive. So f dash of x changes its sign from negative to positive, that is decreasing to increasing. So you will get the minimum. So as f dash of x changes its sign from positive to negative when passing through x is equal to half, so therefore the function f of x has local minimum at x is equal to 1 by 2. So we have located the place and you are going to find the minimum value. For that, x equal to 1 by 2 has to be substituted in f of x, and you will get, if you simplify, your answer is minus 3 pi by 4. So the second result we have completed. The next one, we have to check the intervals of concavity and point of inflection. So you know the procedure. So everything has to be used in terms of the second derivative. Already we have found the first derivative in this curve. So the first derivative is f dash of x. What is it? It is 12x squared plus 6x minus 6. So this has to be differentiated. So 12 is a constant, and if you differentiate it as x squared, it is 2x plus 6x is a 6x, you have to differentiate, 6 is a constant, and if you differentiate x with respect to x is 1, and minus 6 is a constant whose differentiation is 0. So the answer is 24x plus 6, and you have to equate to 0. You will get that point x is equal to minus 1 by 4. So only one point. So we have to make an interval. What is the interval? Minus infinity to minus 1 by 4 and minus 1 by 4 to infinity. So in this interval you have to take the point and it has to be substituted f double dash of x. So take a point x equal to minus 1. If you substitute, it is minus 18. Okay, so minus 18 is negative, so it is concave downward. So minus 1 by 4 to infinity, you can take x is equal to 0. If you substitute, it is 6. You have to substitute in f double dash of x. So it is positive, it is concave upward. So concave upward in this interval, concave downward is in this interval. So minus 1 by 4 before and after that, there is a change in the f double dash of x, negative to positive. So this is the point of inflection. So this point has to be substituted in f of x. So if you substitute and if you simplify in f of x, you will get the answer as 21 by 8. That is the point of inflection as minus 1 by 4 comma 21 by 8. Thank you, students.